distributed systems course. So in this lecture that we will understand Raft. Raft is a consensus algorithm that is used in distributed systems for leader election and log replication. For those use cases that we use a Raft, it's a consensus algorithm. It's an alternative to Paxos. So previously we discussed about the Paxos. It's a consensus algorithm that is used. Also we discussed about the single degree. It's a simple Paxos algorithm, but here we will see one simpler version, and it is used in some other databases for data collection and log replication. So the algorithm is called Raft. So the use case that we are going to discuss here is that data collection and log replication. So these two use cases that we will discuss. So how the distributed systems that we build uses a Raft consistent algorithm. So we will discuss here that how the Raft is used in distributed systems for data collection and log replication. So first we will here let's create a simple distributed system setup. So this is it, and we have a node. This is a node N1. So we have a distributed system setup. So initially, all the term we are going to discuss about the thing called term. Term is represents a number. This is the first term, second term. Initially, it's 0. It is initialized for all nodes. It will be initialized to 0. So when all the nodes are up, so the first thing they have to do is that check the leader. So if there is no leader, first they have to make a request to all the other nodes in the system to elect a new leader. So there are three things that we have to understand for leader election in Raft. The states are leader, candidate, and follower. So these are the three states that we will discuss. Initially, all the nodes will be in the follower state. So then it will look for leader. So if there is no leader, so then it will become a candidate. So every node can become a candidate. Now candidate is a state which the node will try to become a leader. So what it will do is here the candidate. So it will increment the term for leader election. For example, if it is a 0, it will increment it to 1, and it will send this to all the other nodes. New term for leader election. The same way, every node in the cluster will increment that term and send this to all the other nodes. So the thing is that instead of all the nodes may not send the request to other nodes at the same time. So there is some timeout, some kind of random delay that is added to the nodes before making the request. So this is called request to vote. So it's asking for a vote. It's kind of election. It's asking for a vote. So same way that all the other nodes are asking for a vote to all the other nodes. So when the request reaches all the other nodes will respond to this. So for example, here if the node receives a term that is higher than the current term, for example, if it receives a 2 but the term is 1, then if it is higher than the current term, then it will send a response. But if it is not higher than the current term, then it will reflect the error. It's for all the other nodes. Then in the candidate, becomes a leader. Once it gets a majority of the vote, the candidate becomes a leader. Otherwise, there is no majority of the vote, then it becomes the follower. So if the candidate didn't receive the majority of the vote, it becomes a follower. So if the candidate received the majority of the vote, it becomes a leader. Then it sends order bids to all the followers. Once it becomes a leader, it will send order bids to all the followers. Now the leader knows all the followers, all the followers. So whenever the new message that is sent from the client, send from the client to the leader, it will be replicated to all the follower machines. Thing is that here how the leader is selected. Even during failures, it will the leader will look for the majority of the votes from all the nodes in the cluster. The majority is not achieved, then the new term is started. The new term is the new election term. Then by the all the other nodes in the system after a period of delay, it will start the new term. So all the nodes will make the request to all the other nodes to elect a new leader. So if the leader is elected, it will receive the followers will receive the request from the leader. Otherwise, all the nodes will become the candidate again. Then it will try to become the leader. So this is how leader election is done using the Raft consensus algorithm. So the next section that we will see how the Raft is used for log replication. So it's the same. So the main thing to understand here is that we are going to replicate the state. State here is anything that is stored in the log. So for example, we are appending some data here log, then it will be replicated to all the other machines. So before replicating to all the machines, it will return the response to the client. So you will see how the log replication is done using a Raft algorithm.